All right, now we know what the allowed row operations are, we can start working towards getting this system of equations into triangular form. To do this, we're going to need to get rid of three terms. The first term is that x right there, and then afterwards we're going to work on getting rid of the 3x, and then also the term that's in this position. Let's look at these one at a time. So first, we want to get rid of this x. So we're going to keep the first and third equations just like they are. And what we need to do is we need to perform some sort of row operation that's going to allow us to change the second equation to get rid of that first term, to eliminate that first term. So the first and third equation are going to stay just like they are, but this second equation we need to do something to eliminate the first term. Now there are a couple of row operations that we could do to eliminate this x here. One of them would be taking the first equation minus the second equation, because x minus x gives us 0. But that's going to end up giving us a negative second term, because we're going to have negative 2y minus 2y. So it's a little bit nicer actually to take the second equation and subtract the first equation. If we call these equation 1, equation 2, and equation 3, what we can do is, for the second equation, we can take equation 2 minus equation 1. This is adding a multiple of equation 1 to equation 2, and that multiple is negative 1 times equation 1. So what we're going to do is we're going to take equation 2 minus equation 1 and write the result here. So if we look at the x terms, that gives us x minus x, which is nothing. So we're going to put nothing right here. I'm just going to put a little highlighted area there to represent that there's nothing there. Then we look at the y terms, and again we're taking equation 2 minus equation 1. So this is going to be 2y minus negative 2y. And we know that 2y minus negative 2y is going to be 2y plus 2y, which gives us 4y. So we're going to have a term of 4y there. Then we look at the z's. And remember, we're taking equation 2 minus equation 1. So for the z terms, that's going to be negative z minus 3z. And negative z minus 3z is negative 4z. And then we're going to do the same on the right-hand side. We're taking equation 2 minus equation 1. So we've got 13 minus 1, which gives us 12. So we've just completed our first row operation. And what that's done for us is it's gotten rid of one of the terms, and we're slowly making our way towards triangular form. Let's look now at the next term that we want to eliminate. Now we're hoping to eliminate this 3x. So we need to use a row operation that's going to get rid of it. We don't need to change anything in the first two equations, in the first two rows. So we're just going to leave those alone and rewrite them in the next step. And now what we need to do is we need to do some sort of row operation that's going to get rid of the 3x. And it's not going to involve the second equation, because the second equation doesn't have any x's, and so that's not going to be helpful for us in eliminating the 3x. Instead, we're going to look at the third equation and the first equation. So we've got this 3x, and we want to get rid of the x. The way that we can do this is by taking equation 3 and subtracting 3 times equation 1 from it. If we multiply this equation by 3, that'll give us the 3x, and if we subtract it from 3x, we're left with nothing. So that's going to get rid of this 3x. Let's look and see what happens to the y's, the z's, and the constants. Remember, we're taking equation 3 and subtracting from it 3 times equation 1. So if we look at the y's, the equation 3 term is going to be 2y, and then minus 3 times equation 1. Equation 1 is negative 2y, so we've got minus 3 times negative 2y. We know a negative times a negative is a positive, so this is going to be 2y plus 6y, and that ends up giving us 8y. Let's look at the z's, and I'm going to be honest, we want to get to the point where we can do this in our heads without writing out all the algebra. So let's try that with the z's and with the constants. Remember, we're taking equation 3 and subtracting from it 3 times equation 1. So here in equation 3, we've got negative 5z, and we're subtracting 3 times 3z, so we're going to be subtracting 9z, and negative 5z minus 9z is negative 14z. Then with the constants, we've got equation 3 minus 3 times equation 1, so we've got 3 minus 3 times 1, that's going to be 3 minus 3, which gives us 0. So now we have 8y minus 14z equals 0. And notice that we have 2 out of the 3 terms that we wanted to eliminate, eliminated. The last thing we need to do to get this into triangular form is eliminate this 8y term. Now, if we want to get rid of the 8y, we're not going to use the first equation, because if we involve this, then this x is going to be involved, and we're going to end up with an x again. So at this point, we only want to look at the second and third equations. Now, we're not going to change the first or the second equations, so we're going to leave those alone and just rewrite them here. So 4y minus 4z equals 12. But now we need to perform a row operation that gets rid of this 8y. And the thing that we can do is we can take the third equation, equation 3, and subtract 2 times the equation 2 from it. If we do that, 2 times 4y is 8y, and 8y minus 8y is 0. So that's going to leave this blank, the y. The x's are blank because both of those were 0. So now we just have to look at the z's and the constants. So we said this was going to be equation 3 minus 2 times equation 2. So see if you can do this on your own. Equation 3 here is negative 14z, and we want to subtract twice negative 4z. So we're going to subtract negative 8z, but subtracting a negative is the same as adding a positive. So we're adding 8z. So negative 14z plus 8z is negative 6z. It might be difficult to do in your head at first. If that's the case, you can write it out to the side. But we really want to get to the point where we can do these mentally. It's going to make things a lot easier. Let's take a look at the constants now. We've got equation 3 minus 2 times equation 2. Well, the constant term in equation 3 is 0. So we've got 0 minus 2 times 12. That's going to be 0 minus 24, which is negative 24. So at this point, we now have our system of equations written in triangular form, and that is the bulk of the work. Once we've done this now, we can figure out what z is, substitute that into the second equation, and then solve for y, and then substitute those into the first equation and solve for x. So let's start with z. We've got negative 6z equals negative 24. To get z alone, we divide both sides by negative 6. This gives us z equals 4. So that is the first value in our solution. Now we want to find y, and we want to do that by plugging in z to the second equation. So we have 4y minus 4 times z, which we've discovered is 4, equals 12. This becomes 4y minus 16 equals 12. If we add 16 to both sides, this gives us 4y equals 28. And if we divide both sides by 4, we get y equals 7. So now we know the values for z and y. To figure out the value for x, we need to substitute these into the first equation and then solve for x. The first equation is x minus 2 times y, which we learned was 7, plus 3 times z. Oops, I had a mistake. This y should be a z. That's not good. I don't think that affects anything. I just copied it down wrong. So anyways, we've got x minus 2 times y, which is 7, plus 3 times z, which is 4, and that equals 1. This becomes x minus 14 plus 12 equals 1. When we combine the constant terms, it becomes x minus 2 equals 1. And when we add 2 to both sides, we end up with x equals 3. So the solution to this equation, this system of equations, is x equals 3, y equals 7, and z equals 4. Sometimes we will write these as ordered triples when it's x, y, and z. So we can write 3, 7, 4. Either of these gives us our solution. X equals 3, y equals 7, and z equals 4.